Hi students, today we will discuss about polysaccharides. So, polysaccharides. So, what is polysaccharide? So, polysaccharide means two or more than two, not two or more than two, more than 100 above. So many monosaccharides combined to form a one big molecule, that is we will call poly. Poly means many. So more than 100 molecules, monosaccharides combined to form a big molecule, that is we will call polysaccharides. So example for these polysaccharides. First one is starch, second one is cellulose, third one glycogen. So starch, cellulose and glycogen. Starch consists of alpha D glucose, So this one cellulose is beta D glucose units. Number of beta D glucoses consist of present in cellulose. Alpha D glucose monomer is alpha D glucose. Here cellulose forms so many monosaccharides. Monosaccharide means single units of glucose. It will combine together to form a big molecule, that is starch. So starch having two components. That two components, what? First I will discuss that two components. So starch, starch is a polysaccharide. It is contains two different components in starch. Two components is there. That is, first one is amylose. Second one is amylopectin. Amylose and amylopectin, two components present in starch. So here amylose is water soluble component. Amylopectin is insoluble in water. It is straight chain polymer, polysaccharide. This is branched chain polysaccharide. Okay, it is. So this one amylose present in 85 to 95% in starch. It is present in 85 to 95% in starch. This is 15 to 20% present in starch. It is straight chain, it is a branched chain. So branches also is there. Straight chain, one monomer another monomer forms carbon 1, C1 and C4 of second glucose units. One glucose unit of first carbon, another glucose unit of fourth carbon will form glycosidic linkage. What is that? Glycosidic linkage. Here C1 and C4 will form glycosidic linkage, and then C1 and C6 will form branches, branch. So, okay, so this is I will erase. This is about amylose and amylopectin present in starch. Starch is main food storage for plants and animals. Food storage of plants and animals. So first amylose structure, how it will be, I will see, we will discuss. See, so amylose, what I said, so alpha D glucose, alpha D glucose structure is like this 6-membered ring. So alpha D means this carbon we will call anomeric carbon, first carbon. So this carbon down OH is there means that is alpha D glucose, OH up is there means that is beta D glucose. Here H, OH, H, OH, H, here OH, H, CH2, OH here H. This is alpha D glucose. Next plus one more alpha D glucose, not only one more, so many alpha D glucoses. So here H, OH, H, OH, OH, H, here OH, H, CH2, OH and H. Same another molecule. So H, OH, here H, OH, OH, H, OH, H, CH2, OH, here H. So here what I am doing is, this is a straight line. Amylose is straight chain polymer or straight chain polysaccharide. Here by loss of water molecule, here H2O we can remove. We can remove one H2O molecule, one O is there, that O will form glycosidic, GLY, glycosidic linkage, or this is alpha D glucose, alpha linkage. So this water molecule also remove, H2O, remaining O will form like this. So after that we will write N, and a number of molecules will form this glycosidic linkage with the help of this 100 to 2000 molecules connecting with each other like this. This is amylose. This structure is amylose. Now amylose, this one amylopectin, how it is there we will discuss. If you want you can take a screenshot, after you can draw this diagram. So all are same compounds, alpha D glucose, anomeric carbon. This is carbon number 1. This compound I will tell 1, 2, 3, 4. Fourth carbon and first carbon, 1, 2, 3, 4. Fourth and first carbon will form, what is the step? This is 1, 2, 3, 4. So first and fourth carbon will form joining that oxygen linkage, that only we will call glycosidic linkage or alpha linkage. So this is about amylose. Next, amylopectin. Second one in starch. Amylopectin. Amylopectin structure, how it is there? See, two same amylopectin also like insoluble in water. So 85 to 95% starch. In starch, this is 85 to 95% is there. So this is one alpha D glucose. So another alpha D glucose also like this is there. Here another alpha D glucose, here another alpha D glucose present. Okay, then here also one alpha D glucose I am writing like this. So now here HOH is there, no, CH2OH here is there, here OH, here H. So here also OH, here H, here CH2OH, here H, here OH, here H, here H, here OH. So H, OH like this is there. Here H, OH, H, OH, here CH2 OH, H, OH, H, here H, OH, OH and H. So all I am writing like this: OH, H, OH, here one H. Then this one CH2OH, HOH and OH, H, OH, H, HOH, here one H. In this compound what happened? So CH2OH, H, H, OH, OH, H, OH, H. So like this is there. Now this H2O will form, one bond. This H2O also will form one bond. Remove H2O, one oxygen is there. That oxygen will form glycosidic linkage. Here H2O remove, one oxygen is there. That one form glycosidic linkage. This is a straight chain. Now branches where it is, when it is formed, this one see H2O. I said first carbon and sixth carbon will form branches. I said first and fourth, first, second, third, fourth carbon and first. 4 and first will form alpha linkage, or we will call that is glycosidic linkage. Now here one more and here also one more side chain. In this H2O we can remove, then remaining part we will write for this CH2O, this is first carbon and sixth carbon, no, 1 2 3 4 5, this carbon is sixth carbon. First carbon, sixth carbon will form glycosidic linkage with what is a branched chain. So here O is there, here CH2O. So this bond and this bond we will call straight chains, branched chains, this straight chain. So here we should write N, or here also we should write N, means n number of molecules joined. So this is amylopectin, insoluble in water, C1 and C4 will form straight chain, and C1 and C6 will form branches. That is important. So this is about amylopectin. Next, second one, cellulose. Cellulose also straight chain. So second one is cellulose. So this is beta D glucose will form, number of beta D glucoses will form a cellulose. So how it will form cellulose? About cellulose, it is cellulose present in plant kingdom. Cellulose is main food storage of plant kingdom, right? Plant kingdom. It is a straight chain poly. It is a straight chain polysaccharide. It is a straight chain polysaccharide of beta D glucose. Glycosidic linkage, where it is? Glycosidic linkage. Glycosidic linkage, where it is forms. First carbon linkage is carbon 1 and C1 and C, where C5, C1 and C5, correct? C1 and C4, sorry, C1 and C4, correct, C1 and C4 place position, it will form a glycosidic linkage. Now I will tell that is. So first I will take here one compound like this. Here alpha beta means here OH is there, here H, this is anomeric carbon H, OH and H, CH2 OH here H, here down OH, this side common OH is there. Same one more compound I am taking here. O, like this. Here OH H, CH2 OH, and inside H, here one OH, here H, here inside OH H. So like this, one more compound I will take here. It is not okay. Even also OH H, here OH inside H here. Here we can take OH H, here CH2 OH, here H. Okay, like this three structures is there. This one and this one. See, 1, 2, 3, fourth carbon. This is fourth carbon. This is first carbon. First carbon of one compound and fourth carbon of one more carbon. That's why fourth and first carbon have glucosidic linkage due to loss of water molecule. So here O, this O connect with like this. Here OH, here H, H2O will remove. Here also same. So here already H is there. Okay, here O connect with like this. OH will be minus, it will be removed. So here N number of. This is a cellulose. Cellulose is a very essential or very important for plant kingdom. It is plant kingdom. So it is a straight chain polysaccharide. Glycosidic link is present in C1 and C4 carbon. This is the structure of cellulose. Next, third one, glycogen. Third one is glycogen. How it will form glycogen? Glycogen also we will call plant starch. Glycogen, third polysaccharide is glycogen. So glycogen is the carbohydrate are stored in animal carbohydrates are stored in animal body okay. So this is glycogen. Carbohydrates are stored in animal body is a glycogen. How it is stored? Animal body carbohydrates like glycogen, it is known as animal starch. Important these 3 points. Animal starch. Why we will call animal starch? Because it is structure. Because this structure is like a amylopectin. Amylopectin you saw, no? One branch is there. Straight chain having branches. So this is like amylopectin. That's why we will call a glycogen. That's why we will call glycogen. Okay. So it is present in where? Liver, muscles and brain. So when the body need glucose, when the body needs glucose, if body need glucose means what will happen? Enzymes breaks down the glycogen to glucose. When body need glucose, so glycogens converted into glucose. So enzymes are act as like cutting, like hydrolysis. So glucose maltose or something disaccharides will hydrolysis, we will get 2 monomers. How? Same enzyme also act as like a catalyst to cut the glycogen into glucose molecules. 30,000 glucose units present in maximum glycogen. So one glycogen molecule contains 30,000 glucose units. So this is about glycogen. It is present in liver and muscles and brain also. Liver, muscles, brain. So this carbohydrate also known as animal starch, because this is like amylopectin only. Amylopectin means what? Alpha D glucose. No, this is also alpha D glucose only, but straight chain as well as branched chain also is there. Straight chain and branched chain. So this is also alpha D, which is monomer in glycogens, means alpha D glucose. So remember this one. So explain about polysaccharides means these 3 you should write, means you will get good marks. Only 2-3 lines only each one. That is a starch. Second one is cellulose. Third one is glycogen. Starch have two components present in starch. That components is what? What is that? Amylopectin and amylose. So amylose is a straight chain. Amylose is soluble in water, but amylopectin didn't soluble in water. So this is about polysaccharides. This chapter biomolecules. Okay, thank you. Tomorrow, next class we will discuss about amino acids, proteins. Thank you.